This video is a review of air masses, weather fronts, and air pressure. We're going to start out with air masses. Remember, there are two types of air masses. An air mass is just a large area of air with a similar temperature and a similar amount of humidity. So cold air masses and warm air masses are just large areas of air that are about the same temperature. We know that air masses don't stay put. They get pushed around by jet streams and each other. So if we have a cold air mass and a warm air mass that are heading towards each other, the cold air mass contains particles that are closer together because they're colder, and so they are not moving as fast and they're not pushing each other apart as far. Warm air has particles that are much further apart. Because of this, the air mass that is warm is less dense, and because it is less dense, warm air tends to rise above cold air. The cold air is going to stay on the ground. When air masses run into each other, the faster moving air mass is going to push the slower moving air mass. So in this first one, we're going to have a faster moving cold air mass run into a slower moving warm air mass. When that happens, the faster moving cold air mass, because its particles are so much closer together and it's so much more dense, it has a lot more force. It's like a bowling ball hitting a bowling pin. Okay, the bowling ball has more mass, so when it hits the bowling pin, it makes the bowling pin move a lot more than it was moving. So that warm air gets shot up very quickly and gets forced up. And those particles, those warmer particles that were in the warm air, as they rise, they cool. And not only do they cool, but the water vapor that is in the air cools as well. Remember that as water vapor cools, it condenses. And when water vapor cools and condenses, it forms clouds. Cold air fronts are drawn on weather maps with little triangles. The triangles point in the direction that they're moving. And these really tall clouds that are formed are big thunderheads. So these are the kinds of clouds that produce severe thunderstorms, hail, lots of lightning, and sometimes tornadoes. Cold fronts are not the only kind of front. There are three other kinds of fronts we're going to discuss. So the next one we're going to talk about is a warm front. In a warm front, the warm air is moving faster than the cold air. But remember that the cold air is more dense. Okay, so just like in a cold front, it's moving faster and it's more dense, so it has more force on the warm air. It's going to push the warm air with a lot more energy. When the warm air is moving faster and runs into the cold air also resists moving. So this cold air, it's going to stay down here on the ground and it's going to force the warm air up, But the warm air is not going to go straight up. In this case, it's going to go up at just gradually. And as it goes up gradually, it's still going to cool, it's still going to condense, and it's still going to create clouds, but not those big thunderheads that we had those in the cold front. In this one, we get lower clouds, we get gentler rains. Sometimes we have snow, but it's just snow flurries. It's not like a huge snowstorm. And the clouds may last and the rain may last for a couple of days. With the warm front, a warm front is denoted by a line with semicircles, red semicircles. Think of these semicircles as little suns. Okay? And so again, just like in the cold front, the triangles pointed in the direction that the cold front was moving. In this case, the semicircles point in the direction that the warm front's moving. Now, we've been talking this year so far, we've been focusing on the warm fronts and the cold fronts, but there are two different kind of extra fronts. These are a little special. So in the case of a stationary front, the warm air mass and the cold air mass run into each other, and they both have the same amount of force. Neither one is strong enough to move the other. And so the symbol for a stationary front is a combination of the symbol for a cold front and a warm front. And neither one is strong enough to move the other, so they stay stationary or in one place until another front comes along and pushes one of them with enough force to move the other. The last kind of front that we're going to talk about is an occluded front. In an occluded front, you have a faster moving cold front that overtakes a slower moving warm front. And because the cold front has greater density, when it runs into the warm front, it's going to force the less dense warm air up. Let's look at an animation of what this looks like. The cold air front from the left is going to run into the warm air front on the right, and as it does that, notice that it's actually forcing the warm air up, and when that cold front forces the warm front up, you get this area down here where the warm front is now cut off from the ground. That is our occluded front, and the symbol for an occluded front is actually, it's purple, and it's a mixture of the triangles for the cold front and the circles for the warm front. And because the cold air is more dense and forcing the warm air, that warm front forward, those point in the direction that they're moving. The last thing that we're going to review is air pressure. Remember, there are two types of air pressure. There's high air pressure that forces down against the ground, and when that air comes down, as it reaches the ground surface, it goes out in all directions. The other kind of air pressure is a low pressure air system, and that is where the air is coming from the Earth's surface and going up into the atmosphere. Now, these two pressure systems have very different results or effects on our weather. With high pressure, because let's see here, get a big pen. Because that air is coming down, it's carrying all of the moisture that's in it down out of the atmosphere and pushing it down to the Earth's surface. So this is where we get clear skies, we have sunny skies, but the low pressure system has a completely opposite effect on our weather. With that, we remember when air moves up into the atmosphere, the particles cool, because the higher you get in the atmosphere, the cooler it gets. Those air particles, some of those particles are water molecules, and as those water molecules get cooler, they get closer together and they condense and they form clouds. So we usually see rain around near low pressure systems. Besides the clear skies or the rainy skies, there's one other thing that is affected or is the result of high pressure and low pressure systems, and that is how they interact with each other. When air comes down towards the Earth's surface in a higher air pressure system, it runs along the Earth's surface until it reaches a low pressure system where it gets forced back up. This area here on the Earth's surface, where the air is moving across it, creates wind. Oh, let's fix that. That is really hard to read. Let's try this one. That is how we get wind on the Earth's surface. Now that we've had a chance to go over everything, if you have any questions about air masses or weather fronts or air pressure, make sure that you message me on Google Classroom or you meet with me at one of the Zoom meetings before you take your quizzes.